Okay, so now we need to look at human impacts on the phosphorus cycle. So the first one we're going to look at is phosphate rocks. Now, because most of the phosphorus that we use as phosphate is locked up in the lithosphere, that's where we have to go look for some for us to use for fertilizer. So what we usually do is we mine sedimentary deposits. So these are typically something like evaporites, and the form that we dig up is calcium phosphate, which we then treat to produce ammonium phosphate. Now this has a couple of benefits. The first is it is more soluble, so it is easier to apply and easier for plants to take up. The other thing, it's got ammonium in it, which would break down in the environment and become nitrates, ideally. So you can see that this is a really useful fertilizer for farmers to use. In the past, before they found sedimentary deposits, calcium phosphate, they would dig up ammonium phosphate from a biological deposit. So this is seabird droppings from large colonies. So this is what we call guano. And the seabirds obviously are going out into the oceans and they are fishing and catching fish. Now these fish have been eating smaller fish, and then the smaller fish have been eating the algae, which have accumulated phosphates in them that's dissolved or washed into the seas. So these fish are high in phosphates and proteins and all that sort of stuff. The birds then catch them. So let's say this is a frigate bird or something like that, with a fish in its beak. They return to land, rarely, but occasionally, to breed. So once a year, they will go to remote coastal areas. Islands are ideal. And if they are in hot, arid areas, there'll be limited rainfall. So what they do is they are going to raise their chicks, and they are also going to produce guano. So the chicks and all this sort of stuff are going to poo all over this island, building up this guano, which is rich in ammonium phosphate. And these deposits are found in places like Peru and tropical islands such as Nauru, which is in the Pacific. Both of these have hot, relatively dry climates, so the ammonium phosphate does not get washed back into the sea. And this means that it built up over thousands of years, and humans came along and extracted all. These have all now been depleted, however. And this is what we face as a risk with our sedimentary deposits, because they are going to be finite reserves as well. So the other issue that we have, we're going to have all the issues with mining associated with this sort of stuff. So mining impacts. And you also get toxic chemicals co-deposited that need to be extracted and disposed of. So that's another impact from that. Fertilizer use. So if we have Farmer Giles or Farmer Gillian or whoever it is happily adding phosphates to their fields so they can increase the yields of their crops to make a profit and feed our growing population. If they badly apply these, so if it rains soon after, or there is not much root uptake because they're adding them to bare soil, and we have leaching and erosion, then we will end up with our phosphates will wash into rivers and lakes and ultimately the ocean. And this will cause everyone's favorite environmental problem, eutrophication. Okay, where we have an algal bloom that then leads to deoxygenation. And this is important. The difference for this between nitrates and phosphates is this erosion aspect. Because phosphates bind with particles in the soil, if those particles are washed away by erosion into watercourses, then you increase the amount of phosphates dramatically in a watercourse. So if we look at some sustainable management options, we need to replace phosphates in soils after harvesting. Because the action of harvesting removes biomass that would have been deposited as dead organic matter, returning nutrients. Because we've harvested these crops, the nutrients that are in the crops are removed from the field and are not returned to the field. So we need to make up the deficit, and this is where fertilizers come along. Fertilizers add nutrients to make up the deficit or shortage. Now, at the moment, we are using phosphates from rock deposits. And these are finite. Now, these finite rock deposits then are not going to be sustainable. Because they're not going to renew within human sort of lifespans. So we should look for an alternative. We should use biological wastes. So this returns that phosphate that was removed as harvested crops and returns them back to the soils. Now this has the benefit of being less soluble and more stable. So biological wastes are quite good at adding phosphates back in because those phosphates won't then immediately wash out. They're not quite as soluble. They're sort of bound up with the biological dead organic matter. So things like manure or slurry or sewage sludge, ideally composted or anaerobically digested. Alternatives include things like making crops better at accessing stuff within the soil, so increasing crop efficiency of phosphate absorption. Let's get the right one. So this is things like mycorrhizal fungi. We want to promote conditions that promote the symbiotic relationship. So this might be crop breeding to make sure the crop is good at making that symbiotic relationship. We might look at things that reduce pesticides. So we might use biological control instead. We might use cover crops. So there's no bare soil. And these cover crops then also provide sort of surrogate plants until our crop is planted. And prevent erosion, so we don't lose that phosphates from the soil. We can add lime to increase pH to make the phosphates more available in the soil, and we can reduce erosion through things like cover crops. We can do contour ploughing, where we plough across the slope, not up and down it, and zero tillage, where we don't actually plough the ground, we leave plant residue in place like stubble, and then plant through that with sort of a blade sower.